Hi everyone. So we're finally ready to graph our last trig functions. So we got secant and cosecant. So remember when we did those big tables and those graphs, secant and cosecant are those weird parabolas because it's based off of sine and cosine and the reciprocals. So let's take a look and see the actual values that we get and what our graph should look like. Okay, so we're going to start with secant. And remember, secant is the reciprocal of cosine. So we should expect some things with cosine to be there, okay? So we know that our period is going to be 2 pi because it goes with cosine. And we'll figure out the domain and range after we graph it. So to help you find those y values, think about what cosine is. So cosine, normal y values are 1, 0, -1, 0, and 1. But we're flipping those over. So that's what our secant values are. So the reciprocal of 1 is 1. We get -1 there and a 1 there. But what happens when we reciprocal 0? Good. We get undefined, which is why we have those asymptotes in this graph. Okay? So let's draw in our asymptotes first. So they're at pi over 2 and 3 pi over 2. So I know that it's going to be kind of hard to remember where asymptotes are for secant and cosecant, and then we had asymptotes with tangent and cotangent. For tangent and cotangent, you just have to remember them. But for secant and cosecant, I just based it off of cosine. I think of cosine and then reciprocal them. So you don't really have to remember the difference between the two if you go back to the basic sine and cosine graphs. Okay, so we know at 0 we're at 1, and I'm going to do each one worth 0.5. So at 0 we're at 1. Then our next value is at pi, we're at -1. And at 2 pi, we're at 1. So I know that doesn't really help us very much, but remember what the graphs look like. They were parabolas. Well, sort of parabola. They kind of look like parabolas, but it's not actually like following, they're not x squared values. So on this one, it's going to go up. This one goes down. And this one goes up. Okay, so one way to remember what directions it goes in is that they always go away from each other. So they're never going to point towards each other. So it's never going to go like opposite. They go away from each other. And remember what we talked about, that if we graph that cosine right in there, they'd be like little bumps on the hills and valleys of cosine, which I graphed right here for you to look at. Okay, so here's our cosine right here, and then we end up with those little bumps on the hills and valleys of cosine. So our domain and range for secant and cosecant is hard because there's a lot of breaks in our graph. It's not continuous. So we have to think of our domain in chunks and our range in chunks as well. So our first part is from 0 to pi over 2. And it's inclusive at 0, but not at pi over 2. So remember, that's going to change brackets and parentheses and stuff. So we have to write this small because there's quite a few. There's 3 pieces. So we go from 0 to pi over 2. And then our next piece, so I put union, which means combining, would be from pi over 2 to 3 pi over 2, which those are asymptotes, so we're not inclusive in either one of those. So pi over 2 to 3 pi over 2. And our last piece is from 3 pi over 2 to 2 pi, inclusive at 2 pi. So that is the domain for this one chunk of our graph. Okay, so we could come up with a formula that tells us, because at every pi, starting at pi over 2, we have an asymptote. So what would be the equation for that, do you think? Think about it and try to tell me next class and see if you can figure it out. So our range, we're down here at -infinity, but we stop when we get to -1. And then we start at 1 and go to positive infinity. So we have -infinity to -1 inclusive And then we start again at 1 and go to positive infinity. Very good. So let's check out cosecant, which is the reciprocal of sine. So we know our period is going to be 2 pi again. So our sine values are 0, 1, 0, -1, 0. So wherever those zeros are is going to be undefined because we're flipping that over. So then we just have 1 and -1. So let's draw in our asymptotes first and see what we got from there. So asymptote at 0, asymptote at pi, and asymptote at 2 pi. I like cosecant a lot better because it's like even. You can see both of the parabolas, not like little half pieces that we got there. And I shouldn't call them parabolas because they're not really parabolas, but that's kind of, that's what they look like, so I do. But just know that they're not really parabolas. Okay, anyway, so at pi over 2, we're at pi, or at 1. So we have our little parabola up here. I can't even stop myself from calling them parabolas. So at 3 pi over 2, we're at -1. So remember, they point away from each other, so that's why it's going down. And if we drew our sine graph in there, we would see that those cosecant graphs land on the sine hills and valleys. Okay, so let's talk about domain and range. So our domain here is a lot easier because we only have 2 chunks. So our first one goes from 0 to 2 to pi, non-inclusive because they're asymptotes, and then it starts again on the other side of pi to 2 pi, non-inclusive. So our range is going to be the same as it was for secant, everything but between -1 and 1. So we go from -infinity to 1, or -1, and then we start again at 1 and go to positive infinity. Awesome. So let's try our examples on the inside. Remember to write down any questions that you have. Okay, so we're starting with cosecant. So remember, that's the reciprocal of sine. So let's find our period, our interval, we'll make our table, and then do our graph. So our period is 2 pi over 2, which we get is pi. Remember, we take that b value. So our interval would be our period divided by 4. Okay, so remember, with sine and cosine, our first value is our shift. So since it's -pi there, we're actually shifting to the right pi. And then we're going to add pi over 4 to get to our next value. So this is like 4 pi over 4. So if I add 1, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So I'm just going to reduce those. Then we have our x numbers. So now we're going to find our y numbers. So remember that cosecant is like sine. So sine would be 0, 1, 0, -1, 0. But we reciprocal them, so it's actually undefined, 1, undefined, -1, undefined. So we're going to apply our amplitude, so times those values by -2. So -2, 2, and then add 1. -1, 3. So those will be the values that we actually graph. Okay, so let's take a look at our graph. Okay, so our graph is all the way over here from pi to 2 pi, but our interval is pi over 4, so I made each box worth pi over 4, so we're moving over a lot. We shifted over a whole period's worth, so that means there's a period of the graph here that we're not graphing. I mean, we could, but we're graphing where our shift starts, right here at pi. So I drew in my asymptotes already. So we have one right here at pi, one again here at 3 pi over 2, and then another one at 2 pi. So at 5 pi over 4, we're at -1. And then at 7 pi over 4, we're at 3. So to graph our parabolas, or whatever. Remember, they go opposite each other. So this one's going to go down, and this one will go up. Very good. Okay, so I want you to try the next two examples, and I know you're probably a little scared, but remember, it's kind of just like doing sine and cosine, except we have asymptotes and the graph looks a little bit different. For the third one, remember that you have to factor out that 2. Okay, so let's do that one real quick, I guess. So we know we're getting rid of the 2. And what I want here is what we would have when we distributed. So the other way to think about it, you're undistributing, so you're dividing. So if we put a 2 out here, we're dividing this by 2. So that would be what our shift is. Okay, so go ahead and try both of those. Figure out your period, find your interval, make your table just like you would for sine and cosine. But remember, you're reciprocating those y values, so you have all those undefined asymptotes. Okay, so go ahead and pause, please. Okay, so for our second example, this is what we ended up with. This was secant, so that was the one where we had 2 little half graphs, or half of our parabolas. So we shifted backwards negative pi over 3, and our period was 2 pi over 3. So that meant we were kind of even on our y-axis, like it's kind of a mirror reflection, line of symmetry right down the y-axis. And then we got our asymptotes at pi over 6 and negative pi over 6. Okay, so for our last one, we did that first part together. So our period ended up being pi, and our shift was negative 3 pi over 2. Oh no, I messed up my graph. It should have been positive pi over 2. Okay, let's do that one together real quick. Okay, so if we shift it positive 3 pi over 2, and then our interval was pi over 4, so we would need common denominators. So this would be 6 pi over 4. So add pi over 4 to it. We would have 7 pi over 4, 8 pi over 4, 9 pi over 4, and 10 pi over 4. So our y values were right with what I had there. I just did my shift backwards. So this is what we should be looking at. Okay, so if we make a graph, so our interval was at pi over 4, so each box is going to be worth pi over 4, and all of our values are positive, so I know it's going to be to the right of everything. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8, 9, 10, 11. So that is all we need to go to. Okay, so our asymptotes are at 3 pi over 2, which is at 6 pi over 4. So we got one right here. And then our next one is at 8 pi over 4, so there's another one right there. And then we're at 10 pi over 4, so we got another one right there. Okay, so then if we plot our points, we have one at negative 4, 2, 4, one at positive 4, 2, 4. So that's what we end up with. Okay, so there we go. Make sure you write down any questions you have, and we'll talk about them in class tomorrow.